All right, area of a region between two curves. Let's back up a second and remind ourselves about the area just under one curve. So before we do two curves, let's back up and work an easier problem. See if we can remember how this works. So I've got some function. I want to find the area from A to B under that function. What's that area equal to? How do I find that area? Integral from A to B of f of x dx. So hopefully that looks familiar. That's the basic area under a curve. Integral from A to B of f of x dx. So that's going to change a little bit today. Area of a region between two curves. This gets real fancy in here, but we're not really worried about this. I think it's going to make sense. In fact, let's just look at the picture. The top function is f. The bottom function is g. So if we want the area between f and g, we will take the area under f minus the area under g. And so, to me, this was always, if you understand this was always maybe not a simple lesson in terms of actually doing the integration, but conceptually it's not hard, I don't think. Just the top one minus the bottom one. And even if these second two pictures demonstrate something a little bit different, if one of the areas or one of the curves is below the graph, it's still the same thing. It's still the top one minus the bottom one. Now, if g is negative, then that ends up being f plus the bottom one. So you end up having the top area plus the bottom area. But the signs take care of themselves if g is negative. Minus a negative will end up being positive. So, and then same thing, if they're both underneath, basically it doesn't matter where they are. It's always top one minus bottom one. Top curve minus bottom curve from A to B. In fact, here's one way to write it. The integral from A to B of top minus bottom. Like wherever they are, above, below. You do have to know which one is on top and which one's underneath, though. Otherwise, you're going to get things backwards. Let's look at example one. All these words, as we go through the problems in this section, this is important. I'm glad we did read this. We will use extensively the calculator ability. So when we get to this stuff, we're going to let the calculator handle the integral, handle the hard stuff. Because the hard stuff for us is setting it up. Once it's set up, we'll let the calculator, Math 9, let him do the hard work. Let's see. On the AP test, you're allowed to use the calculator's ability to numerically integrate as long as you show the proper setup. So as long as you've shown what's going on, then you can go to the calculator and let him do the work. So grab a calculator if you need one of mine. They're in the second shelf from the top over there. So we are definitely going to be using some Math 9 today. Yeah, Math 9. Greatest invention, maybe not ever, a little extreme. All right, example one. Find the region bounded by the graphs y equals x squared plus x plus 2, y equals negative x equals 0, and x equals 1. Okay, well, it's sort of sketched for us, but we have to know which one is which, so we know which one is the top one and the bottom one. I mean, x equals 0 and x equals 1, that's easy. Let's call y1 and y2. So, which curve is, or which equation is this top curve? Is that y1 or y2? And how do you know? How do you know it's the first one? Okay, that's a great answer. The y-intercept's at 2. How else do you know it's the first one? It's the only one that's a quadratic. It's a parabola. It's a quadratic equation.
Yeah.
Nick's right.
Yeah.
Oh gosh, I just put that on video for everyone to hear that Nick is right.
Oh, that's good.
That's saved forever.
Oh, yeah.
So the bottom one is just the line negative x, so that's y2. The integral is, so we'll set up the integral. So what are the limits from what to what? 0 to 1. And then we need to do the top one minus the bottom one. X squared plus x plus 2. Minus the bottom one, oh careful, minus negative x. And that one is straightforward enough we could do it by hand, but they invited us to use the calculator, so why would we not? 0 to 1, x squared plus x plus 2. I mean, and you could type it in exactly like it looks. Like you can do some simplifying if you want, or you can just say, that's the calculator's job, minus negative x. He can figure it out on his own. Enter. There's my answer. So this unit is more about setting up an integral, letting the calculator do the work. And in fact, on the test, quite a few of the multiple choice questions are just set up the integral. So you don't even have to take the time to type it in. It's just which of these setups is correct. All right, example 2. Find the region bounded by the graphs of y equals 6 minus x squared and y equals x. And I'm going to call those y1 and y2 just so that we name them something, but also it's going to matter more in a minute. Sketch it, integrate. Oh, to integrate we must find the intersection. So I got to know where they intersect so I know from where to where. So the integral, I don't know the limits yet. Now, since I've labeled them, I'm gonna shortcut this, and I'll show you how to put it in the calculator even. I'm just going to call it y1 minus y2. And that is acceptable showing your work because you told the grader, you told me, what y1 and y2 are. So I don't need to write them all out. I can just call it y1 and y2 as long as I have them labeled y1 and y2. Now, I need to know where they intersect. So where does 6 minus x squared equal x? So x squared plus x minus 6. If I move everything over. I mean, we have a picture, so we could guess that it's 2 and negative 3, but let's make sure. So, yeah, sure enough, they intersect at negative 3 and at 2. So from negative 3 to 2. You could also have your calculator do that. You could put both of those in the calculator, have the calculator find the 2 intersections. In fact, I'm going to do that because sometimes that's really the only way to do it. This one worked out nice. That won't always be the case. So y1 is 6 minus x squared. y2 is x. Better change my window back to something normal. Negative 4 to 4. I'm going to make it match the picture on the page. And then negative 6 to 6. And that should match pretty close to my picture on the page. Second calc, intersect. I don't know that we've used intersect. I don't know if you've used it before. This one was easy, but if you get two weird equations that you can't algebraically make work, then you let the calculator handle it. First curve. So it walks you through. What do you want for the first curve? Y1 or Y2? Well, it doesn't matter as long as you pick a different one for the second curve. Guess. Well, go get close to one of the intersections. And we get -3. I mean, we knew that one already, but again, for harder problems. Second calc, intersect, first curve, second curve. Guess I want to go get closer to the other one now. So you can, again, for crazier functions, you'll have to do this if they don't work out nice. All right, math 9. From -3 to, -3 to 2. Now, since my calculator now knows what Y1 and Y2 are, I don't even have to type in all of Y1 and Y2. I can use those variables. There's a button there for vars. Where is it? There it is. Variables. Y variables. Y1 minus vars. Y vars. Y2 dx. So this one wouldn't have been too bad to type that stuff in, but again, if you get really weird, ugly equations and you type them in anyway, then you don't have to type them in again. You can use Y1 and Y2. Do you guys get 20.8333? So I think the concept is pretty easy, top minus bottom. It's just the details of finding intersections. In fact, we look at example 3. Find the region bounded by the graphs of x equals 0, y equals sine x, and y equals cosine x. So there's sine x. I'm going to label them 1 and 2 again. Cosine x starts at 1, so we'll call that one y2. So I'm looking for that region. Your first job is to find the intersection of these two curves. Do it algebraically. Well, algebraically would mean set y1 equal to y2. All right, unit circle people. Where do sine and cosine equal each other? Pi over 4. Remember, they're both root 2 over 2 there. And I guess if you had a calculator, you could do that. You could also see that pi over 4 is between 1/2 and 1. So the integral. Why don't you see if you can set it up? See if you can finish this one. Set it up and then type it in, and we'll see if we get the same thing.
Well, I still got the same 4.414. I just don't know. Did you do sine minus cosine?
Did you do sine minus cosine?
I did sine minus cosine.
And so there's a bit of a built-in check. If your answer turns out negative, then something is wrong, and the likely guess is you got it switched. Who was the top one and who was the bottom one? So it's, if you're pressed for time, you can just ignore the negative and put the positive and hope that that was your mistake. But that might not have been your mistake.
Well, we put y equals sine x as y1, did we not? So wouldn't that, or is it because?
Well, y1 is sine x,
starts at 1.
but the top one is cosine.
Okay, so it's not about like the first one that we put. It's about like.
Correct. It's about which one is above.
Okay.
So it's not always 1 minus 2 or 2 minus 1. It's the top one minus the bottom one. That's a really good question. Let's skip number 4. No, we can't skip number 4. We'll go quick through number 4. Looking at number 4, it has 3 intersections. And to save time, I'll just tell you that those intersections are what they look like they are, -3, 0, and 3. The trouble is the top one minus the bottom one, because it changes. Does that make sense? Like, we color-coded this. Let's see, one's a cubic, so it's easy to pick which one's which. So there's the cubic one. The other one's squared, so we'll call that one y2. So if I'm supposed to do top minus bottom, it switches right there. So any idea on how we could handle this? Just do two integrals. So this will be one integral, -3 to 0 of the red one minus the blue one, plus, and then from 0 to 3, the blue one minus the red one. So I'd have to split them up because top and bottom changed, and there's no way to account for that other than to split them up. All right, let's look at number 5. Speaking of splitting them up, find the region bounded by the graphs of all of that stuff. 3 of them. So y1 is the only one that's a parabola. So that one's an easy one to identify. y2 equals -x. Well, there's only one of them that has a negative slope, so that one's not hard to identify. And then that last one, y3, is that one. And so we want to find the area bounded by those. So that area is all of that. So this is a weird one here. So how am I going to do this one? 2 integrals again. Use all my colors today. So that orange integral let's see. Well, I would need to set these things equal to each other, but we can assume that that goes from -6 to 0. And then what's my integrand for that? For the what am I integrating on this for this side? Which one's the top? Which one's the bottom? y1 minus y3 dx plus 0 to 4 of the top one on that side is, oh, again, y1, but the bottom one is y2. So again, today the calculations aren't hard because the calculator does all the calculations. It's just you understand what the picture is. Can you find the intersections? You understand top and bottom, which one's which. All right, let's do one more. Example 6. This one is turned on its side here. Find the region bounded by x equals 3 minus y squared. Okay, you don't usually do x equals type graphs. But it's the only one that's squared, so I'm pretty sure it's this way. And x equals y plus 1. Which seems that's a weird way to describe it, but it's got to be the line, so there's the other one. And the area it wants is this area. Okay, this one is weird. This one always throws people off. Rather than integrating using x, so rather than having x slices, which is what we have been doing, now we want to take slices with y. So the width of that is dy. So all my variables are going to be y variables. My limits are going to be in y. My integral is going to be in y. Everything's in y. So what are my limits? From what to what? You got to look bottom to top, not left to right. -2 to 1. Because we're looking at the y. -2 to 1. And then instead of top minus bottom, we got to do right minus left. So the right one is 3 minus y squared minus y plus 1. And again, we could type that in the calculator and let the calculator do the work for us. We're not doing example 7. On the homework, we're going to omit number 12. We're going to omit number 14. And on number 13, it's a setup, but do not solve. So give it a try. You may be able to set it up. If not, that's okay. We'll have time tomorrow to go over these. So give them a try. Tomorrow's a block day, a little bit of a catch-up. Go over them, make sure we're okay.